Okay, let us start the program now. Dear participants, we wish you all a very pleasant good afternoon and welcome you all to this webinar on artificial intelligence from research to operations. Undoubtedly, this is an era of artificial intelligence. As God has made man from dust and breathed life into him, now the same mankind has made a machine out of materials and has been trying to breathe life into it. The life is nothing but the artificial intelligence. Before we get into the webinar, I take this opportunity to welcome the Chief Resource Person, Mr. IRFAN Ali, a solution architect by profession from Kongsberg Digital, Norway. On behalf of the management, the principal, the staff and the students, and on behalf of all the participants, we extend a warm welcome to our Chief Resource Person, Mr. IRFAN Ali. Welcome, sir. Next, I would like to welcome our Chairman, Lying Dr. M. Stalin Arikaraj, and our CEO, Ma'am, Professor Dr. Birjet Nirmala, the Chief Patrons to this webinar on artificial intelligence. On behalf of everyone, we welcome both of you, dear sir and ma'am. You are most welcome. Next, I would like to welcome our Principal, Professor Dr. S. Karpakam, our Dean, Professor Dr. V.G. Kopinath, the Head of the Department, Professor K.P. Chiepan, the convener of this webinar, Professor Thamari Muttumani, and all the other staff and students of our college. Finally, let me welcome all the participants from various other engineering colleges across the states. You're all most welcome to this webinar on artificial intelligence. Once again, we welcome you all. Thank you. Now, before I hand over the session to the resource person, Mr. IRFAN Ali, let us tune our ears a little to listen to a brief intro about our resource person. Mr. IRFAN Ali is by birth a Pakistani and had his education from one of the leading universities of Pakistan. He had his bachelor's degree in software engineering from Ghulam Ishaq Khan Institute of Engineering Sciences and Technology in the year 2009. He has got more than 10 years of experience as of now. He has specialized in data warehousing, software design patterns, and web engineering. He had started his career as business logic developer in Softida, which is a USA-based software house. Then he worked as global delivery control consultant in Teradata, a Sweden-based company. There he played a vital role as data mapper in data warehousing team. After this assignment, he worked as an IT data transformation specialist. He has been part of Rolls-Royce Marine Application Delivery System. Then he worked as a lead data architect in Rolls-Royce Ship Intelligence Division 2. After this assignment, he moved to the present company Kongsberg, Norway. He has been the solution architect of data and cloud. Finally, at present he is working as solution architect of Marine Digital Solutions. We are happy to welcome you to be the Chief Resource Person of today's webinar on artificial intelligence. Now, I request Mr. IRFAN Ali to take over the session, please.
Thank you. Hope you guys can hear me. Thank you for a warm welcome, and you guys have done your research on me. Thank you for reminding the university time and my first job. Yeah, it's been 10 years. So I've also prepared a little bit like some kind of presentations. So I'll just quickly go through this one. So, and I'm going to minimize this. You guys can hear me, right? Arpita, can you hear me? Okay. Okay. Yeah. So, yeah. Today I'm going to be talking about the machine learning operations and how it is used in the industry in general. I'm going to start with artificial intelligence, basically what it is. As I know, most of the students that are attending are bachelor level students, so I'm not going to be touching a lot of advanced subjects, but at least I'll try to get you guys interested so that you can do some research on your own. So there was a really good introduction. I'm work as a solution architect. I'm just basically a data dude. I love data, anything there is to data. Software engineer by education, currently working in the maritime sector with Kongsberg Digital, Norway. Jumping into it, basically artificial intelligence is incorporating human intelligence in machines. The way we behave, the way we decide on right and wrong, the way we decide on what time we need to leave so that we should be on time, the way we behave in a traffic situation and following certain rules and laws. That's intelligence. And we want machines to basically behave in such manner. By machines, I mean computer-based systems. It's an all-inclusive term. Usually they use the good old-fashioned AI, and it also includes modern techniques, which I'm going to talk about. It's based on rules, how we set up certain rules and how the computer should behave, but it's also based on data, a lot of data and algorithms, like different types of algorithms that we could use, be it linear regression or be it neural networks. These are some of the terms that you need to know for at least getting an idea about artificial intelligence. Basically, artificial intelligence is divided into two groups. One is the narrow intelligence, artificial narrow intelligence, and the other one is artificial general intelligence. Now, narrow intelligence is basically, if you look at the picture, you have a car on an assembly line. These robots have one job: to weld particular joints in the car frame. So basically what happens is that they know their specific task. I don't expect this robot to get a glass of water and without breaking the glass or without spilling the water. So that's like narrow intelligence. It's for a specific purpose. While artificial general intelligence, and I'm using this image from an iRobot movie. This was released long time ago. But when we talk about general intelligence is like human level intelligence, where we have to make a decision between right and wrong. We have to act in a certain scenario, which might be like walking without falling or cleaning some place. So these are like generalized cases of intelligence. In a nutshell, we have artificial intelligence at the top, and then we have machine learning. So machine learning is basically a subset of artificial intelligence. It's about making computer systems learn and perform based on learning. It requires data, a lot of data, to be effective. And there are recursion through the data. So the computer has to go through the data again and again, and each of this step going through from data A in the data to the Z in the data, it's called epoch. So they have to do like 1,000 rounds of that data to basically learn on how they can effectively predict the outcome. Basically, it is prediction on top of data. There are different techniques for doing this. This is regression. We have the deep learning, the neural network, and there are so many of them that you can use. And in the industry, they are being used right now. For example, if you look at the self-driving modes of different cars like Tesla, it has a self-driving mode. You have the Facebook face prediction. So if I upload a picture on Facebook, and what Facebook does is basically looks at the picture and looks at my gallery And then say if I have a friend who kind of matches that, so it will try to recommend me whether this is Mr. Thomas or not. So that's an example of it. Then we have the Google and Facebook ads. You might have searched for a new laptop, and the next day if you open Google or Facebook, you get ads about it, that okay, maybe you might be interested in this. And the last one, which is my favorite one, I actually have one of this. I'm not going to call her right now. It's a Google Home. You just have to basically say the name, and then you tell them to turn on Spotify or turn on Ghana.com. Usually I have Ghana.com on my Google. So then it can play a certain music, right? Or you can say that, hey, yeah, I'm not going to say it, but hey, Google, turn on the lights in my bedroom, or turn off the lights in my bedroom. So basically it listens. It's more like a case of general intelligence, right? Usually it takes, all of this happens through characteristics of data that we feed in. So on the right side, if you see, I have a table, small table, where I have given like weight of an object, and I have given a texture, like how it feels when you touch it. For example, if I touch this glass, it has contours, right? And it's kind of roundish, but it's more like multigonal shape. If I touch this Rubik cube, I have like a cube here, right? And I have flat surfaces of this one. So this is basically the texture of this one. And then the weight. Glass has a different weight. It can be heavy. If I have a lot of water, my son wouldn't be able to pick it up. He's 3 years old, but he can definitely pick this thing up. So it has a weight. Yeah. So if you look here, you have the texture and weight. And if I say that, okay, if it is something in between 150 and 190, and it's rough texture, it is orange. And then if I say that if it is something between 100 and 140, and it's smooth, so it might be an apple. And this is what I tell computer, that you have to look for these two things, weight and texture. And based on that, the computer might be able to predict that, yes, it is below 140 degrees and it is smooth, so it might be an apple. So that's how basically machine learning happens. Just a small example on how this whole thing works inside the computer system. Is there a question? Just to give you an example of, I'm going a little level up right now, and I'm going to talk about pipeline. Basically, pipeline is, you might have seen like the water system anywhere, right? You have water source, like a big tank of water, and then you have the water coming through the pipe, and it basically comes in your washroom or in your kitchen. So kind of similar principle. We have here is basically a data frame. A data frame is basically a set of data. We get large amounts of data. I'm talking about billions and billions of rows of data at an industrial scale. On a test scale, you don't need a lot of data. If you have to do a project or something like that in your university, but when you're working in an industry, you have a lot of data. So what we do is basically we take that data, we call it data frame, we split it into two sets. One is for training purposes, the other one is for the testing purpose. And then what we do is we apply the machine learning algorithms on it, and we try to extract features from it. Feature is basically an individual measurable property or characteristic of phenomenon being observed. So if I go back to this example here, I have texture, which is a characteristic, and weight, which is a measurable entity. So basically this is what my features were. And then I train my model. I say to my model, look at these characteristics, look at this feature of weight, look at this feature of texture, and then try to come up with calculation, try to find a pattern here. So basically, if I have to be very mathematical about it, I'm going to say it tries to come up with a linear kind of equation, y is equal to mx plus b, where m and b are those features, right? Sorry, m is a constant, x and b are the features for this one. So yeah, and then it basically evaluates it. And at the end of it, I get a mathematical equation in the form of a computer code, that I use to carry the testing on it. So I had same data, I had split it into half. One I used for training my model or developing my model, and then I used a separate data set for basically testing my my hypothesis, like whether it is right or not. So I'll have a separate data set where I'll have multiple weights and multiple texture, like a set of them. And then I will test my case. And I know the result. I know the result that, okay, I've actually picked up an orange, weighted it, it was 160. It has a rough texture, but then I would test my model on it and ask my model whether it is an orange or an apple. And if the model says it is an orange, then it's a good model. If it says it's an apple, then there is something wrong. And I need to retrain my model again, maybe increase the data set a little bit. So this is a generic pipeline experiment phase. Is it okay if I take the questions in the end? Because a lot of these questions will get answered during the presentation. Now, I have for you guys a quick experiment on basically, we all have done it. I think it was in my 7th grade or 6th grade when I was studying. We used to remember these formulas for converting centigrade to Fahrenheit or Celsius to Fahrenheit. So today, I'm going to quickly demonstrate to you how can I write a machine learning code that will train on a data set and basically give me output of a centigrade in Fahrenheit. So let's do this. So the example that I'm using is basically from Google Colabs. Colab is a research-based Google system that basically allows you to test different algorithms. And if you feel like your computer is not powerful enough to do a lot of processing, I'm talking about millions and millions of processing, then you could use them. They have student accounts, so you can basically subscribe to that. And they have a lot of tutorials. And I have set up links in the presentation that I can talk to you about later. So what I'm doing is basically I'm using TensorFlow, which is Google open source library that helps you build machine learning models. And then, so all the code here is in Python. Data scientists, machine learning experts love Python, just so you guys know. Yeah, so I'm going to execute them each step by step. So I have an import TensorFlow and an NumPy, and I'm going to be logging something. So I've executed this step. Now the next step, I'm just enabling the logger so that I could log the activity of what I'm doing. Now in this step, what I have is an array of different temperatures in centigrade, Celsius, centigrade, same. Array is just a collection of different values. And then I have Fahrenheit in array as well. And these are corresponding values. So for -100, it is -148. This is my initial data set. Like, you know, I told you the texture, texture and weight. So this is consider that as that one. And then I have a little bit of code, which basically kind of makes like a matrix of it, like combines the two together. Like I know from my general intelligence that 100 is -148, -100 is -148, but I have to tell computer that it is actually like that. So if I execute this, it will show me that -100 is -148, 37 degree is 98.6, which is a really important one. A healthy person has a 98.6 temperature. So in Pakistan, we still have 98.6, but in Norway, we use 37. So yeah, we kind of following US there. And then I have some code. What basically it does is that it is using some optimizers and a dense ranking. Since this is a very simple experiment, it is it doesn't involve really complex calculation. Like I'm not trying to find out that if an object in a picture is basically a ship or a train. No, I'm just converting numbers, and numbers are really easy to deal with. So I'm using the very basic layer or library in there, dense. And then also I'm using an optimizer. What optimizer does is that basically it will go through the data set, this small data set, like 1,000 times, because I have told it to go 1,000 times here. And what it will do is it will try to come up with a number that will make it easy to, or that will make it not easy. Easy is not the right term. It will optimize it. It will make sure that I'm getting close to the actual formula that the scientists have found out. It doesn't know the formula yet, so it's just predicting right now. And when I execute this, basically it is training right now. And you see that it finished in less than 2 seconds. But if I had to do this on my computer, the one that I'm working with, it will take at least 5 minutes. Because 1,000 times going through the data, no. But right now what I'm using is basically some cloud services, free cloud services from Google to allow me that I could use it for educational purposes, and I can do the processing really quickly. So training has finished. It was looking for it. And if I show you the outcome of this training, I'll be basically drawing a graph. So initially, in the graph, you could see it was way off target. Like, it couldn't predict. But slowly, using mean square error, I told it to go a little below, go a little below, go a little below. And when I was on 1,000 epoch, which was the 1,000 cycle of data run, I got really close to 0% error on my model, which is a good thing. So now what I'm going to do is basically just use any temperature. I have minus 50 degrees, but I can change it to minus 99, my favorite number, and see what it is. It says minus 146.183. So what I'm going to do is that, let's see, I'm just going to write here minus 99 C to F. This is a Google shortcut. 146. And here I have, 146. So see, that's how close it was. And as you saw, it took me like, what, 5 minutes to write something that could replace a scientist, not a scientist, but a mathematician who could basically help me with the formula. And now I have trained the computer. Every time the computer gets a value in centigrade, it will return a value in Fahrenheit, as close to the actual value as possible. So just a quick experiment with you guys. I'll share this code. This is not my code. I took this code when I was learning about it, about the machine learning from Google Colab. And I found it like, I don't need to write my own code. It is something I could show to the guys and show them. And this is one of a really beautiful example because it's a day-to-day example. You will remember this. So going back to my, my slides, what I showed you was basically a manual process. Like I had to get data, I have to combine data, I had to basically do all the testing, do all the tweaking bit, making sure that 1,000 cycles were enough and everything like that. This was a manual process. And you have to realize that most of the data scientists or the machine learning experts that work in this area, they are PhD in statistics, PhDs in mathematics, or they are people who have industry experience. Like I've known data scientists that have been in the maritime sector for 10, 15 years. And they know the sector really good, but they don't know much about software engineering. All they know about is the hull of a ship, or the crane on a ship, or a drum on a ship, or the bridge on a ship. Like, you have this where the captain sit. If you guys have seen Captain Phillips, that's called bridge, where Captain Phillips used to sit. But they don't know much about software engineering. So what they do basically is they extract data from offline sources. They prepare the data. Data preparation is one of the most time-consuming job in machine learning. It takes around 80% of a data scientist's time to get the right data. 20% is just model training and tweaking the model. So, and it's a lot of data. That's why it takes a lot of time. So you have the data preparation step. You have the model training, which I just did, like for the C to F. And then model evaluation and validation. What I did was I gave it a number. It gave me the value in Fahrenheit. And then I checked against Google, which is like calculator. I don't want to have a thermometer right now checking both, right? So I just use Google. And then I said, okay, yeah, it works. And let's publish this so that someone can use it. So I kind of make it like put it into a model registry. Model registry is like a place where you have all the models, the machine learning models listed with what was the purpose for them. It's like a catalog, you know. In libraries you have catalogs. If you go to a library where they have information on this one, or yeah, like, you know, in the student register you have a catalog of students. These students are in this university, they are in this particular class, and they're attending these subjects for this semester. So kind of we have a model registry similar way. And then we serve the model. Usually the technologies that are used are containers. Kubernetes is one of the example. Also Docker is another example. Well, they're not container Kubernetes, but yeah. So you have basically these methods of deploying these models in a real world. It could be a car, it could be a ship, it could be an aeroplane, it could be a website. It could be anything. If the model is for a specific purpose, you basically deploy it. And then it starts the prediction services. But what you see, there is too much manual stuff here, right? You have to wait for the data preparation. You have to wait for the model training before you could, you know, evaluate it and then deploy it. What DevOps basically did was that in the DevOps, in the software DevOps, you have basically continuous integration and continuous delivery. So you work in a small chunk of application or service. You test it continuously. You continuously deploy it. You continuously again test it, and you provide feedback to the developers that this thing worked in this manner. Maybe you could improve this a little bit, and it kind of takes, like, you know, this infinity symbol where you go. Of course, in a regular software world, you have to put a baseline. Okay, this is what my product looks like. Till I achieve this, I'm going to continue with this iteration of continuous integration and continuous delivery. But in machine learning case, we use the similar. So that was software DevOps. Now we have the ML DevOps or MLOps. That includes continuous integration and continuous delivery. It basically, what it does is that it also incorporates continuous training. And that is, it automatically retrains and serves the model. So if we found out that my model was not behaving properly for minus 275, which is, like, you know, the absolute zero temperature in Kelvin, it wasn't perfect enough because my data set was from minus 150 to 200, right? So I didn't include the bit very early, like, you know, the absolute zero temperatures. So then what I would be doing is basically I'd be retraining my model with those extra values for where it didn't behave in the proper way. So I would use the MLOps step to basically retrain my model, make a new version of the model, put it in the repository, and then deploy it with known characteristics. So basically, it's a software DevOps process which has the continuous integration and continuous delivery, but it also has the continuous training bit of it, which makes it more interesting because, as I said earlier, you have people who are not software engineers by education. They are not software engineers by experience most of the time. They're not in any way expert. They are PhD guys or subject matter experts who know about a particular industry really good. And this MLOps, what it helps it kind of makes a marriage between those people from that area where it's more technical for them, where it's more mathematical for them, statistical for them, to people who are more in the software processes. And between you guys and me, it is the perfect time to be a software engineer with a little bit of data experience. It is the best time in our history right now. So this helps us a lot. We get to work we get to work with really interesting people, but we also get to work with really interesting technologies. And MLOps help us bring machine learning, which is kind of artificial intelligence, into the software DevOps world. And if I go into the MLOps stages, now this slide has a lot of information on it. You have basically the develop experiment step here, which was what I showed you in my experiment, a little bit of experiment on the C to F. And I have a source code, right? I've written in Python, and it basically does what it wants to do, what I want it to do. And then what happens is that basically I take that, I'm okay with it, and then I put it in the software development pipeline with continuous integration, and I make packages out of it, right? Packages is something that I can basically put in the pipeline, and I say, deliver this package to this particular asset for execution. And then I have the pipeline, which is the continuous delivery pipeline. It will have multiple packages coming in from different teams in the artificial intelligence. Some people might be working, for example, in the maritime sector. Some people might be working on making sure that the engine is performing good. So they have like algorithms where they listen to the sound of engine, and then based on that, they come up with the failure modes, like what would make this engine fail. Some of the really experienced mechanics for cars can actually listen to the sound of engine and then say, well, there is a problem over there. You all might have heard stories of people, when they just knock like with a small hammer and they know what is the problem. So it is real. It actually happens. It was a surprise to me, but it is real. It actually happens this way. But how do we replace that? We write a code that listens for sound patterns, like, sound waves. And then it looks into like, okay, I'm going to take this bit where the engine from this whole graph, I'm going to take this bit and I'm going to look at this particular bit where I'm going to see, okay, this was a bit anomaly. Like, there was something wrong. It was usually like a perfect sine wave, but then all of a sudden it was really oscillating. So they look for those patterns. But there might be other team which would be working for the bridge system, Captain Phillips, where he used to sit, looking at the ocean and trying to come up with like, sea marker. You have like these things on the sea where it tells you whether don't come near here because there is like low seabed here. But there is also pleasure boats, like, or fishermen's in the sea, or there are like big Panama class or Suez Canal class, or South China Sea class. I don't know. Ships which are really huge, and they're carrying maybe oil from the Middle East to the US or China, or carrying goods from China, or carrying coal from India to somewhere in the world. That kind of stuff. So these people, what they do is basically they have models which have, so they're using sensors like cameras, day and night cameras. It could be thermal cameras. It could be regular wide angle cameras. And what they do is basically they try to identify whether it's a big ship, a small ship, what type of a ship it is. Is it a fisherman boat, or is it a UT boat, or is it is it a bulk loader, like, for the grains or food, or is it an oil tanker which has, or an LNG tanker coming in from Qatar to India or Qatar to Australia, or whether from Australia it's a bulk loader with sheeps in it. What they basically do is they try to identify, they draw boxes around it, and then they link those boxes to the database of ships. And so you have like two different models, one for engine, one for finding what is in my vicinity, what is in my surrounding. So you have both of these in the same pipeline. Now, if I let these guys, the machine learning scientists, deploy everything, it will be a chaos. I have to use my software DevOps for this purpose, making sure that all of them can work, all of them can get good feedback to our customers, but without compromising the whole the production environment where, I have all my application running. It does not have only my machine learning application running, but it also has my operational systems running, which tells me about how much is my speed right now, or how much is my fuel consumption right now, or how is the weather like, even that, or how will the weather be in next 2 days, because I'm in the sea. It can get really nasty over there. So it will basically take those models, and then what happens is that since I tested my code on small data, like I think it was 10, 15 records that I tested on, but now I want to test it on millions and millions of records, right? So what I do is I put my model in the repository somewhere here, and then I send it for continuous training. So it brings in new data, and then it uses the same model, and basically it starts testing that. I'm not doing it manually. Initially, I was doing it manually by giving it what data it was. Now my software process is basically handling all of this. And once it's trained, when it has gone through a certain epochs, I'm going to repeat, it's the iteration through data once. So that's one epoch. What I did in my experiment, I went through the 10 element array 1,000 times in 2 seconds, but that was a really fast system. So it basically does that thing, It takes that new data, millions and millions of rows of data, and it goes through for a set number of time, right? And then when the model is trained, it will send it, like it will ship it to the location where it's supposed to work. And what happens during that time is basically at the end of this process is basically it will monitor how my machine learning model is behaving. And if it feels like it is a little bit off, like, instead of giving me minus 114 Fahrenheit, it was giving me minus 113, and my system is not so critical system. Like, it's not a nuclear reactor. It's basically a fishing tank, right? And the fish can tolerate 1 degree difference in the temperature. I'm not talking about extreme temperature. I'm talking about the usual range. Within the range, they can tolerate 1 degree difference. Then what it would do is it would basically send it back to continuous training, right? Which will retrain the model again with new data set and then deploy it again, making sure that, we have continuous learning happening. So it's the part of MLOps. But if it feels like, I was expecting it to be in the north, but it is in the south, then it's a problem. What we do is we go back all the way to the initial experiment, and we tell the data scientist, your experiment worked with smaller data set, but on a larger data set, it wasn't behaving the way it should have been behaving. So, and then the whole process starts again. Like you see here, we have the pipeline with the continuous integration packages, continuous training model, and then continuous delivery. And then we go into the monitoring phase of it. Of course, there are tools like Jira used for this one, Microsoft DevOps being used for this one. We have TensorFlow used for in this process. You can use, and funnily enough, you could use PyCharm for writing your code. You could use Jupyter Notebooks for this. So each of this stage, you have Jenkins, all of these tools. I intentionally didn't put tools on this MLOps stages, because when you go into the field, you develop a taste for a certain tool, and then you just work with it. For me, it's PyCharm. Whenever I'm writing Python, I work with PyCharm. When I'm working in C#, I write my code in Microsoft Code. Jenkins is how your DevOps people are going to decide whether you're going to use Jira, whether you're going to use Microsoft DevOps. It's just a matter of how the whole organization should. And then, of course, you have the release guys, you have the integration guys, you have the deployment guys, you have all these people in a hierarchy and during the project that you guys work with. It brings me to my last page. Any questions? I'm happy to take them right now. I have intentionally left around 20 minutes for questions. Some of the links that I'm gonna ask you guys to go, I think when I started with this Nadu courses. This guy starts from really basic. We don't have to be really good in maths. I'm an engineer. I'm not so good with math. No, I like maths. But I'm not an expert in maths, right? I don't call myself an expert in mathematics. So this guy was explaining really good to me, how can I go towards in this field? And then also towards data science, it's a Medium link. You can read, I think, 5 articles for free in a month, which is more than enough. but I use it a lot. I have a subscription of this one. You can get a lot of articles, and there is this guy, I think he's a South Indian, working in Google. I don't remember his full name, but we all call him Lack. I have actually met him. I've met him at a Google event. We call him Lack, and Lack is really good in explaining, and he's really easy in explaining different machine learning modules. He has articles on this one medium as well. And then of course you have the Google Cloud Solutions, which have like certain architectures on how you can do, so you don't have to reinvent the wheel. If you're working in a gaming industry, they have like a stencil for it, like how should you do gaming. Of course, you build on top of that. It's not going to be 100% solution, but it helps you 50, 60%. And then rest of the 40% is your brain and how you can basically use it. And there are a ton of resources, but these are what I have used and I continue to use. Yeah, that's pretty much my presentation. Any questions? Just before you guys ask me questions, some of the I have used copyright images from Google and Microsoft and Medium, so not most of these images are mine. Yeah, just a copyright thing.
Sir, we have a few questions.
Yeah. I'm gonna stop sharing for now. How do I stop sharing? Yeah, stop sharing. Yeah, I've never used Zoom before. So yeah, guys, ask me questions.
Okay. Yeah, we have a few questions from the students. Shall I ask those questions, please?
Do I have to read them in the chat?
No. You don't have to. I will read the questions for you.
Yeah. Go on.
Okay. The first question is. Just hold on. What is the meaning of model registry?
Model registry. Yeah. So model registry is basically a location where you can catalog different machine learning models. So I can share. I might have to share my screen again to explain it. Desktop 1, desktop 2, and then I go to this one. Yeah, and I say share. Yeah. So on this one, basically what I did here, this is my model, right? This is what my model looks like. I have used a certain optimizer. I have used a certain layering technique. And then what I got in return was basically a model, right? You see here. This is what my model initial statement was, and this is how I use it. So now what I would do is catalog it. This model I developed, which is the what is the date today? Yeah, today I developed it at 10:45 Norwegian time on Wednesday, 10th of June. And it basically does is that it converts Celsius to Fahrenheit for a certain range, right? And then tomorrow, if I tweak this one again, I'll create a new model. And when I put them in a registry, is basically to have to uniquely identify which model I developed and what was its purpose. That's model registry.
Okay, thank you, sir. We have another question. The question is, the data will undergo. This is by Dr. A. Kannan.
Your voice is breaking.
Do you get the question?
No, your voice was breaking.
I'll come again. what type of training the data will undergo?
Yeah, so there are different training techniques, right? Like I said initially in my presentation here as well. So on machine learning slide, you have the regression, right? Where you basically use the mathematical linear regression, or linear regression is one of them, which takes polynomial of 1 degree, and y is equal to mx plus b, or x is equal to a y plus c, right? That's one type of training. So what basically you're trying to do is find the value of a, like making sure that the value of a is as close to the ideal that when I multiply. So if I write here, right? Okay, let me just write here. And if I say x equal to a y plus z, right? So what I'm doing is, in the training phase, what I'm doing is that I have two variables, which is the weight and the texture, right? And x is my ideal outcome. So when I'm training, what basically I'm training is, I'm actually training for this parameter. This parameter has to be as close to the reality as possible. That's why I used the root mean square, RMS technique, so that when I multiply a with y and add it to z, I get x. This was the same principle. So here I have on the training side, if I look on, I didn't execute this last one, but if I execute this, you could see that it's basically here I have just give me a minute. Yeah, so it's as close to 1.8 as possible, and 32, because ultimately what happens here is that if I write here, usually the formula for conversion is F equal to 1.8 C, which is the centigrade, plus 32, right? This is what we have been taught in school, that if you want to convert, this is the formula for this one. Now, if you see here, these were the two variables that I was trying to calculate, right? Y is equal to mx plus b, right? So 1.8, I was calculating during the training phase, and I used here deep learning, which is another way of calculation. There are multiple ways you can do model training. Deep learning is one of them. So for this case, in the deep learning, this value is as close to 1.8 as I could manage. And then also my 32 is as close to this one. So it's 31.9. So basically the training is, you use either deep learning, or you use regression, or you use any other technique that is out there. There are tons of techniques, and people are working on this one to basically come up as close to the reality as possible based on what you know. And then you use that technique to predict what you don't know. Yeah.
So we have one more question.
Go on, I have time.
Yeah. What is the difference between classification technique and optimization technique? This question is raised by one Mr. Parakumar.
Yeah, classification technique and
optimization technique.
Yeah, so this is a classic example of optimization, what I'm showing you right now, because you're trying to optimize these two these two numbers to come up with a value that is as close to the reality as possible. But when it comes to classification, so I said earlier, I gave you an example of classifying vessel type, classifying a ship type. That's a different technique, where you don't deal with numbers, you rather deals with pixels and dots. One example is cancer prediction. Like, they are able to predict cancer, skin cancer, with this technique, and they're doing a much better job than doctors are. My wife is a doctor, so I should be quiet. But yeah, so they're doing a really good job and assisting doctors in finding out basically what type of it is. So One is numbers based, the other one is more like pixels and pictures and videos. To a very crude example of this one, really crude example, basic concept is one is classifying things, the other one is optimizing numbers to come up with a number kind of an output. If you want, you can have a look, and if you want more detail on this one, Andrew's tutorial on Coursera, I think it's free. And he has explained it in a really good detail. I just touched the very top of it.
Okay, thank you so much, sir. And we have one more question raised by one Mr. Kannan, and the question is, what is ODSG? SG.
Okay. BSGB. I'm not sure about that one. Did I talk about this one?
I don't know. This is a question raised by one Mr. Karnan. I don't know whether it is relevant to this webinar or not. But we have one more question by one Ms. Elilarasi. The question is, sir, can you describe about POS tagging, NER of characters and words? How can be used in Spider?
In Spider, okay. Character tagging. Oh man, that's an area I have very little work with. I'm not in character recognition stuff. I'm sure there are Google libraries, APIs to do that. I would suggest that have a look at some of these Google already built-in libraries, or not open libraries, where they have used like character recognition. They have APIs for that. I would suggest have a look at that. And they have really good tutorials on that. I have usually worked with machines, mostly like equipment, and how to find the failure modes in that. And then I have also worked a little on the classification side, where how to detect a vessel as a data engineer. I haven't worked much with, it's a really huge field, guys. You can't be a master of everything. I'm still learning. And I just haven't had a need for this one, sorry. But it's a good thing. I'm gonna write it down, and I'm gonna do some research on that one. Thank you for giving me a topic to research.
Now we have almost come to the end of this live webinar, and I'm here to propose a formal vote of thanks. First of all, we express our profound thanks to the research person, Mr. IRFAN Ali, the solution architect from Kongsberg Digital, Norway. Sir, the manner in which you have articulated your points is so astounding. We could see the power of natural intelligence that creates artificial intelligence through this webinar. Thank you, sir. Next, I would like to thank our chairman and CEO ma'am, the chief patrons of this one-day webinar. I also thank our principal ma'am, Professor Dr. S. Karpagam, our dean, Dr. Vijay Gopinath, the HOD, Professor K.P. Chepan, and the convener, Professor Thamare Muttumani, for her untiring work towards the success of this webinar. Let me extend my sincere thanks to each and every participant for their overwhelming support and participation. Let me also thank the technical team and staff members of CSE department for their cooperation. Let me thank each and everyone who have contributed towards the success of this webinar. Thank you, one and all. Thank you.